Good morning. It's Tuesday, May 26th, I'm pretty sure. And believe it or not, this is week 11 of online learning. And this is our final chapter, statistics. Hopefully you have been checking eSchool and checking your grades in there. If you see a little red exclamation point and you've done that Google form, you've done that Castle Learning, please email your teachers or whatever teacher you have, and we're trying to every few days update those grades and getting ready for the end of fourth quarter. Now, statistics is a way to describe data, the measures of central tendency that we're going to take a look at today. You've seen all of these, I think, already. Very easy. There are two different branches of statistics, and we are looking at the descriptive ones this week. Descriptive are statistics that describe data, and they are facts. You cannot argue descriptive data. If your average is a 75, you can't argue that it's a 99. The numbers, when you add them up and divide, is a 75. There's no, well, I think it's a little higher. There's no fudging that. The other branch of statistics is called inferential. And inferential, you've probably been seeing a ton of it on TV going through this coronavirus. They have studies that say that, whatever, this medicine improves your symptoms, and that is inferential. Maybe it does, maybe it doesn't. That's not a fact. Descriptive uses numbers and it states facts. Now we are going to look today at the 4 measures of central tendency. They all start with an M. I have a smiley face for the one I like the best and a frowny face for the one I like the least, but these are my personal opinion. Now they measure, because they're central tendency, they measure the middle of the set of data. So all 4 of these are different ways of finding the middle. So all 4 of these should be not exactly the same, but pretty close. So if you have a mean and a median and a mid-range that are all the same and the mode is somewhere way out, you probably don't want to use that one. But you should notice that when you find your measures of central tendency, they should all be pretty close. Now the mean you've had tons of experience with, because this is how we find your average and your 5-week average and any type of mean. This is the symbol for it. It's X bar, because it's an X with a bar over it. And we compute. There's a formula, a mathematical formula for average or mean. You add up the data values that you have, and you divide by the number of data values you have. Now, the mean is affected by extremely high or low data values, which we call outliers. So this is a non-resistant measure of central tendency. If you're humming along in a quarter and you've got all 90s and then all of a sudden you get a 75, your average is going to drop. That's affected by an outlier. On the other hand, if you have all 70s, maybe an 80, and you get 100, your average is going to jump. So it's good, it's bad, whatever, but that's just something that the mean is. It is affected by outliers. Now, resistant statistics, like the median, that's why I put it in the box, the median is our resistant statistic. It's less affected by the outliers because it's the middle data value. It'll move a little bit. If you have a whole lot of small values, we'll see later on in this lesson, and a few high levels, your median will kind of move a little bit to the left towards those lower values. But it is the middle data value, and it is always in the middle. It doesn't matter. If you have, I'm just going to do a little scrap here. If I do 1, 1, 1, 1, 10. There are 1, 2, 3, 4, 5 numbers, 10, 11, 12, 13, 14. That's 14 over 5. I'm going to say that the mean is about 3. That's your average. The median, though, is still 1. So the median is not affected by that 10, which is really big, but the mean is. So that's what we mean by resistant. Now, neither one of these, this one's a little bit better because, almost all your scores are 1. This is a little bit more accurate because it does have a 10. So that's what we mean by resistant. If you happen to have, now this was kind of nice because I had 5 data values. 5 data values, you work from the outside in. Here's your median. I'll put a little arrow. Here's your median. Whoops, you're not supposed to see that stuff that's up there. Median is 1. If there's another data value, suppose I put another 1 in there, then you would have 2 middles. You won't have a middle data value with 2 different, with an even number of data values. There's 2 that are in the middle, and then you would just average those. If you have 6 data values, you take the middle 2, average them, and that's your median. Your median is not affected by outliers, which we just saw. Now, I don't like the mode as a measure of central tendency. I think they threw it in here only because it starts with an M. But the mode, you can have a data set that has no mode. So I don't know how that shows you where the middle is when you don't have one. You could, because it's the data value that appears most often, the mode could be the smallest one. If your data set starts with 5 2s and then it has 8 more numbers, your mode's a 2 and it's the smallest. It could be the largest. You could have more than one mode. You could have no mode, which is why I think the mode is an awful measure of central tendency. The only thing the mode really works well for is if you're in business and you are doing inventory and you are selling. You want to know what sells the most. That's your mode, and that's what you're going to stock when you start ordering stuff. And then the mid-range. The mid-range is a quick, easy way to find an approximate mean. It is because it starts with a mid, it's in the middle. It is the average. If you take the highest score and the lowest score, add them up, divide it by 2, you're going to get the mid-range. If you take the minimum grade plus the maximum grade, you always divide by 2 because it's you only have one minimum and one maximum. And this tells you if you take the high and the low and divide it by 2, you should end up in the middle. So these are your measures of central tendency. And if you put these, you can do these by hand. The calculator has and here's my calculator, has a stat key, which makes this really easy. So I'm going to just move this up a little bit. Here are, this is number 1. 1 is not a data value. 2 is not a data value. Those are just, the first 2 problems. So I went to, there's a stat button because we're in stats. I just pressed it. Edit means that you can enter or take out data. You can sort your data. You can sort it ascending order, descending order. You can clear lists here. And then if you happen to delete your lists, if you go to edit and you don't have list 1, 2, 3, 4, 5, 6, you've deleted some of them. So you could go to setup editor, hit enter, and it will bring those lists back that you may have deleted. But anyways, I put in, here's my 1, 2, 3, 4, 5, 6, 7, 8, 9. I use 10 numbers here because 10 numbers are always good. 10 numbers means there's not going to be any rounding. They're going to be all nice numbers. So I just entered them in. You type, enter, type, enter. And what's nice is you don't even have to count up to see if you have 10 numbers. The calculator will do that. At the bottom, it says L1. That's called an index. It says L1 is 31. That means the first data value is 31. And if I come down here, it says L7. That means in list 1, the 7th number is 39. It will index. That way it will know when it gets to the bottom that it's got to add these numbers up and divide by 10 because there's 10 numbers. So I enter all the numbers in. I'm going to go to, and I'm going to put this right here. So stat, edit, and then you enter data. I'll move that over so you can see it. That's step 1. Stat button, enter, and you put your data values in. Then you are going to go, and you've probably already done this, I'm just doing this just in case you forgot. You go over to calculate, because the calculate key will calculate some stuff. Now we put one variable in, one set of data. That's what's called one variable stats. So you're going to go to one, I'll just do var, just the way it says. One var stats. I'm going to hit it. Now, my data is in list 1. If something happened and you don't have a list 1, you can put it in list 2, 3, 4, whatever you want. But you have to tell the calculator what list your numbers are in. Frequency list we'll get to tomorrow. And calculate. And there is your mean. Your mean is 41.2. Because there's, and you can see right here, there's 10 data values. I count them first, and then I always check the end to make sure that I didn't skip a number, or I type, sometimes you type in the last number and you forget to hit enter and it doesn't show it. But there are 10 numbers that I wanted to put in, and also I put my data in and then I check it to make sure I type them in. I type kind of fast, and sometimes you'll put in the number, I have a 48. Maybe you hit 48 and you do it so quick the 4 comes up but the 8 doesn't. So I type the data in and then I go back and check it to make sure the data values are the same. So there's my mean. It's 41.2. I'm going to put them across here. Mean. And then if you arrow down, some of this other stuff we'll get to. If you arrow down, and that's what the little arrow means. The little arrow means you can arrow down for more stuff. And the median, MED, is 40.5. Now notice how they're close together. They're supposed to be. They measure the middle of the data, and the numbers so far are looking kind of close. I'm going to skip mode for a second, and I'm going to go to mid-range, because I don't like mode. I'm going to leave it for the last. Now if I look, here's my formula for mid-range, and they will tell me the minimum grade is 23. If you keep arrowing down, anytime you see an arrow, that means there's more stuff. When the arrow stops, that means you now have to arrow up and you can't go down anymore. But the minimum is 23. The maximum is 63. So we're going to do 23 plus 63. I'm pretty sure that's 86 divided by 2 is 43. Still pretty close. Now there is no, as you look through here, there's no mode here. There's a median, there's a maximum, they have your quartiles, you have your number of grades, you have the stuff up here, which is what all the numbers add up to. And you'll notice we had 10 numbers. The 10 numbers add up to 412. You divide by 10, that's at 41.2. But there's no mode. Now mode, remember, is the data value that appears most often. And the easiest way to find the mode is if your numbers are in order. So I'm going to go back to stat, and I'm going to tell the calculator to put my data values in order. So I'm going to sort. You must tell the calculator right here what list you want it to sort. If you only have one list of numbers and you say sort, it's still going to ask you what list, even though there's only one list there. So I'm going to put second L1. And you'll notice above all these numbers, there's an L. So if you want to put a list number in, it's got to be 1, 2, 3, 4, 5, 6. And it stops there. You only have 6 lists. So I put in, please sort list 1. And then it's nice enough to tell me I'm done. So now, if you go back to L1, you'll notice that those numbers are ordered. Whoops, hello, there's the stat. So I have, I'm going to put it up here so the numbers get a little bigger and you can see them. I got 23, and then you look down and you see if anything repeats. There is no numbers that repeat. I got 23, see, and I got to the bottom, I kept hitting the bottom arrow, it takes you back up. 23, 31, 33, 39, 40, 41, 40, nothing repeats. So that means we have no mode. So those are your 4 measures of central tendency. And then I starred this because I would like you to find these 4 measures of central tendency here. And tomorrow, I'll start the video by telling you what those are, and we can compare. Okay, one more short thing about data is data can be symmetric. Symmetric means, and this is what's called the normal bell-shaped curve, and the normal bell-shaped curve occurs when the measures of central tendency are equal or close, and the data is symmetric. If the mean, median, mode, mid-range are all the same, probably not mode, because the mode's probably, it could be in the middle. If they're all the same and located at the middle, you get what's called a bell-shaped curve. Now, if the median, now to determine whether something is skewed, that's our term here, you only look at the median and the mean. Now, if the median is larger than the mean, that means you have a whole bunch, because the median is the middle term, and if the median is over here, it means I have a whole bunch of big terms and not so many small terms. And that means it skews off here. So if you have a median that's bigger than the mean, you are skewed left. I always say if your numbers are bunched to the right, you're skewed to the left because you skew off. Now, in order to be symmetric, your mean and your median have to be equal. Not kind of equal, not sort of equal, equal. And if they are not exactly the same, it could be skewed. So it might look like a normal curve because maybe this is 32.1 and this is 32.3, but if they're not equal, it's not symmetric. And finally, if the median is smaller than the mean, that means you have a whole bunch of small data values and the median got pushed over here. The median's supposed to be in the middle, but the fact that you have all these small numbers pulled the median this way, but because the mean is calculated using those large values, the mean is pushed this way. So the median is smaller than the mean. You are skewed to the right. And in other words, bunched to the left, skewed to the right. And then here is the last set of numbers I did. Here's these numbers that I put in. I put them in my list too. So I went in here. Here's my 146, 143, 81. I put them all in here. There's my list too. And then I did the same thing. I went to stat. I went over to calculate. It's still one variable. You put in one set of data. Do not go here because this is the second set of variables we put in. This means I'm putting in 2 different variables like height and weight, and I want to compare them. You are only looking at one var stats. But this time, my data is in L2. So I tell the calculator, hey, these are my L2 numbers. Here I am. This we'll talk about tomorrow. If there's a number there, just clear it out. And I'm going to calculate. There it is. Now, because there's 15 numbers, I have a mean that's not, it's a repeating decimal. It's not really accurate. So I'm going to put for mean. It should tell you what to round to, but if it doesn't, there's a statistical rounding rule that says round one place past your data. And since my data doesn't have any decimal points, I put in 1. I'm going to arrow down for my median. That's 102. Look at how these are not. They're pretty far apart. These are supposed to be the same. I'm not looking at numbers that are the same. So I'm going to say there's some skewness in here. And skewed, whether it's skewed, you're going to tell by looking at your data values. If the data values, the measures of central tendency are very, very close, it's going to look more like this. As you see separation between the mean and the median, you're going to have some type of skewness there. My mid-range, whoops, I don't have my I in there. My mid-range, sorry for Mrs. Berg students, I know she writes like so impeccably nice and mine's not as nice, but some things you just have to live with. We're going to add those up. Now remember, when you put these in, if you're going to do it yourself and not in your head, 70 plus 150, make sure you hit the enter button first. And make sure, some people see range and they say, oh, I have to subtract to get a range. But this is a mid-range. So the mid-range is an average and you have to add, and then you divide by 2. Now these two are nice. Look at how close those two are. That's good. This median means skewed. There's some skewness here, I think. And now we're going to try to find the range or the mode. So I'm going to go here. I'm going to sort. You can sort in descending order, ascending order. It doesn't matter. But this time I'm going to sort list 2. And then as I look through, it tells me I'm done. I go back, stats, enter. And I look. Here's my list 2. And I'm looking for numbers. There we go. I have an 86. That's a possibility for... I'm going to do it down here. Here's my scrap. So here are my possible modes. 86. It's not a definite mode because maybe something appears 3 times. So I have 86 appears twice. And that looks like it, right? I got to move this up so I can see. I'm just going to go back up and make sure. 150, 147, 46, 43, 34, 29. Okay, so this has a mean of 86. Or a mode of 86. If another data value appeared 3 times, it would kick the 86 out. If another value appeared twice, there'd be 2 modes. So there we go. Those are our measures of central tendency. Now the very last thing I'm going to do is I'm going to take a look at the mean and the median. The median is small. So I'm going to put up here, I have a small median. It's smaller than the mean. Therefore, you are skewed, just like it says up here. Median is smaller than the mean. My numbers are skewed to the, are bunched to the left because of the small median, and my data values are skewed to the right. Okay, there we go. This went a little longer than I thought, but you know, I tend to get a little, I talk a little bit too much. So here, just put these values in your calculator and see if you can find these. Mean, median, mode, mid-range. For this one, and also, where'd it go? Don't tell me. And also number 2 here. And then I'll share those with you tomorrow, and hopefully tomorrow's video will be a little shorter. Okay, enjoy the warm weather, because it's only going to be warm another day or so, and then it's going to go back to being kind of chilly. Okay, take care. See you soon.